In my previous two lectures, I had explained how three-step distance protection scheme is implemented using impedance relays and more relays. Now, in first case, that is when we use impedance relays for implementing three-step distance protection scheme, we require separate directional element. The reason is impedance relay is non-directional. Therefore, we require a directional element separately in order to provide directional feature to the scheme. When we use more relays in three-step distance protection scheme, we don't require separate directional element because more relay itself is directional relay. Now I will discuss how to implement three-step distance protection scheme using one directional relay and two non-directional element. So here I will use one more relay and two reactance relay at single place. In previous case, it were three more measuring units. In last to last, there was one directional unit and three impedance measuring unit. Here we use one more element and two reactance element. So we will consider the same diagram, that is same system, a radial feeder having source at both the ends. There are three line sections AB, BC and CD protected by relays R1, R2, R3, R4, R5, R6 respectively. Now all the relays are having directional feature because sources are at both the ends. Again we consider the relay R3. So this relay R3 is having two reactance measuring element, that is for first step and second step, and for third step we are having more element. I will explain the advantage of this type of scheme afterwards. So in the first step, this is reactance element, so it is covering 80% of the line length and setting will be in terms of reactance. So 0.8 x AB. I'm sorry, this will be 0.8 x BC. This is XBC. In the second step, it is entire line XBC plus 50% of line XCD. In the third step, it is complete line XBC and complete line CD. So first step, reactance element covering 80% of the line. So setting is 80% of XBC. Operating time T1 is equal to T, that is without any time delay. Second step, that is also reactance element. Setting will also be in terms of reactance. So it is XBC plus 50% of line CD. Operating time T2 is T plus delta T. Third step is having more element. So setting will be in terms of impedance. So it is ZBC plus ZCD. Operating time is T3, that is T2 plus delta T. Now I will explain how this is transferred in the RX diagram, how the characteristic is plotted in RX diagram, and in the same RX diagram I will show the location of fault F1, that is first step fault, F2 that is second step fault, and F3 that is third step fault. So this is RX diagram. We locate the relay at origin, so point B, line BC, line CD, and before this relay there is line AB. Now we draw this in the second step, we draw the characteristic of impedance measuring elements used to protect each section. That is, in the first step we are using reactance relay. So reactance relay is having characteristic straight line in RX diagram parallel to resistance axis and passing through the reactance setting of the relay. So this is 0.8 x BC. So this is the intersection point. So this is the first step characteristic. Then in the second step, again it is reactance relay. Characteristic will be straight line and setting will be this complete line X BC plus 50% of line CD. So it is passing through this point. And third step is more relay. For more relay, characteristic is a circle passing through origin having diameter is equal to impedance setting of the relay at angle tau degrees with respect to the resistance axis. So for the third step, it is more relay. So impedance, so setting will be in terms of impedance, and impedance setting is ZBC plus ZCD. So this is the circle. Now third stage is you have to locate the faults in this RX diagram. Fault F1 is in the first step, fault F2 in the second step, fault F3 is in the third step, and let us say fault F4 is in line AB. So if you see fault F4, that is not coming in any of the positive torque region or operating region of these relays, because now the operating region is intersection of characteristic of all these three relays. So if you look at fault F1, it is not coming in the operating region of any of the element. So for F4, the relay is not going to operate. It means the relay is having inherent directional feature. Now consider fault F1. It is here. It is coming in the operating region of first stage, second stage, as well as third stage. First step, second step, as well as third step. So all these three measuring elements will operate. And operating time required is T, that is without any time delay. If you look at fault F2, it is not coming in the operating region of first step. So X1 will not operate, but it is coming in the positive torque region or operating region of X2 and Z3. So they are operating. Time required is T2, that is T plus delta T. Fault F3 is coming only in the third step. So only Z3 will operate, and operating time required is T3 is equal to T2 plus delta T. Now let us see how this part is implemented using circuit diagram. So this is the strip circuit or circuit diagram. This is strip coil of the circuit breaker, timer coil. This is normally open contact of third unit, that is Moe measuring unit. First setting element, that is X1, that is reactance measuring element. This is the normally open contact of second element, that is reactance element. T2 and T3 are the normally open contacts of the timer element. Now let us see what happens when there is fault F1. F1 is coming in the operating region of Z3, Z2 and X1. So all these three elements will close. 1, 2 and 3. So as soon as X3 and X1 close, the trip coil of the circuit breaker is energized. So there is no intentional time delay. So for F1, the relay is operating or circuit breaker is operating without any time delay. Now for fault F2, Z3 and X2 will operate. This X1 will not operate. So trip coil will not be energized instantaneously. Now Z3 is operated, so this will energize the timer circuit. After time T2 seconds, this contact of the timer will close. So now the trip coil of the circuit breaker will be energized through Z3, X2 and T2, that is after time delay of delta T seconds. Now consider fault F3. It is in the third stage, so only Z3 will operate. This will remain closed, open. This will remain open. Only this will operate. So timer coil will be energized. After time T2 seconds, it will close this contact. But X2 is open, therefore trip coil will not be energized. After time T3 seconds, this contact will close, and then trip coil of the circuit breaker will be energized through this T3. So all these requirements are fulfilled by this trip circuit. Now here if you observe, Z3 is operating for all the faults. Therefore it is called as fault detector or starting element. Z3, X1 and X2, they are measuring the impedance. So X1, X2 and Z3, they are called as measuring element. So it is serving as measuring element as well as starting element. Now if you compare this with the first scheme, that is implementation of three-step distance protection scheme using impedance relay. Same scheme we can implement using reactance relays also, but in both the cases we require separate directional element. So that is additional cost, because impedance relay as well as reactance relay, they are non-directional. If you compare this with the previous scheme, in the previous scheme we had implemented the same thing by more relays. All the directional elements are there, but cost of more relay is more. This is by using this scheme we are achieving economy because we are using two non-directional elements and one directional element. So this is the best scheme which is implemented as three-step distance protection scheme, and it is by using one more element and two reactance elements. So that is all about implementation of three-step distance protection scheme. Friends, if you feel this video lecture useful, then please like it. Subscribe to my channel for upcoming video lectures on high voltage engineering and power system protection. If you want to make effective and efficient use of time, then read my book on time management. The link for the book is given in the description box. I have launched a useful course for the students in Udemy. The title of the course is Boost Your Learning and Become Top Achiever. This course is very useful for the students who are preparing for competitive and entrance exams, especially who are preparing for JEE and NEET exam. The link for the course is also given in the description box. Thank you.